algorithms. So, what is data structure? A data structure is a definite is a particular way of storing and organizing data in our device to use the data efficiently and effectively. And data structure array, steering, linked list, matrix, or grid stack queue heap has three data structure: binary tree and graph data structure. What are algorithms? Informally, an algorithm is nothing but a mention of state to solve a problem. They are essentially a solution. What is an algorithm? In computer programming terms, an algorithm is a set of well-defined instructions to solve a particular problem. It takes a set of inputs and produces the desired output. The algorithm is expressed in the form: description, flowchart, and pseudocode. To check two number, take two number inputs, add number using the plus operator, and the last display the result. You can see the next qualities of a good algorithm. Inputs and outputs on the be defined precisely. Each step in the algorithm should be clear and unambiguous. Algorithms should be most effective among many different ways to solve a problem. An algorithm should include computer code. Instead, the algorithm should be written in such a way that it can be used in different programming languages. So algorithm examples. And example one, you can add to number entered by the user. You can see the picture here. And the next algorithm to find the largest number among three numbers. You can see to here. Okay. And then find the factorial of n here. We learn data structure and algorithms, efficiency, comparison at uh, two, 200 to input for two iterations or adds 100 to input. Okay, exercise, create an discrete flowchart, procedure code example, program the code secret text to actual text. EXP is equal h and z equal a and y equal a etc. Okay, thank you everyone. Linked list data structure. What is linked list data structure? A linked list is a linear data structure that includes a series of connected nodes. Where each node stores the data and the address of the next node. The example hit data next, data next, data next, and no. You have to start somewhere, so we give the address of the first node a special name called hit. Also, the last node in the linked list can be identified because its next portion points to null. Linked list can be of multiple types: single, double, and circular linked list. Representation of linked list. Let's see how each node of the linked list is represented. Each node consists. You can see to here structure node in data, structure node then and next here, and a data item and address of another node. Understanding the structure of a linked list node is the key to having a correct trust on it. Next, representation of linked list. Each trust node has the item and a pointer to another struct node. If you didn't understand any of the lines above, all you need is a refresher on pointers and structure. Representation next hit one next to next the next node. This is a presentation of linked list. In just a few steps, we have created a simple position of all the subsequent elements. Linked list utility. Lists are one of the most popular and efficient data structures with implementation in every programming language like C, C++, Python, Java, and C hashtag. Apart from that, linked lists are a great way to learn how pointers work by practicing how to manipulate linked lists. You can prepare yourself to learn more advanced data structures like graphs and trees. Linked list complexity to time complexity, the search and word cache, average cache, and on-in, on, insert, or one word cache, average cache, this one. Space complexity, on. Linked list application, dynamic memory allocation implemented in stack and queue in Undo functionality of software has stable graphs. Linked list operation, traversal access each element of the linked list, insertion adds a new element to the linked list, deletion remove the existing element, set find a node in the linked list, sort the nodes of the linked list. Things to remember about linked list. Head points to the first node of the linked list. Next pointer of the last node is null. So if the next current node is null, we have reached the end of the linked list. In all of the example, we will assume that the linked list has three nodes, 1, 2, and 3 with node structure. Traverse a linked list. Displaying the contents of a linked list is very simple. We keep moving the temp node to the next one and display its contents. When temp is null, we know that we have reached the end of the linked list, so we get out of the while loop. 1. Insert at the beginning. 1. Allocate memory for new node. Store data. Change text of new node to point to head. Change head to point to recently created node. Insert at the end. Allocate memory for new node. Store data. Transfers to last node. Change next of last node to recently created node. You can see to here for running the program here. Insert at the middle. Allocate memory and store data for new node. Reference to node just before the required position of new node. Just next pointers to include a new node in between. This one. You can see to here for running the program. This structure node memory data new node and new node. Next, delete from beginning. Point head to the scan node. This one. Next, delete from end. Delete from end refers to second last element and its next pointer to node. Delete from middle refers to element before the element to be deleted. Change next pointers to exclude the node from the chain. Third, an element on a linked list. You can set an element on a linked list using a loop using the following steps. We are finding item on a linked list. Make head as the current node. Run a loop until the current node is null, because the last element points to null. In each iteration, check if the key of the node is equal to item. If the key matches the item, return true, otherwise return false. Queue data structure. What is queue data structure? A queue is a useful data structure in programming. It is similar to the ticket queue outside a cinema hall, where the first person entering the queue is the first person who gets the ticket. Queue follows the first in, first out rule. The item that goes in first is the item that comes out first. The example you can see to here: empathy queue, enqueue, enqueue, and then dequeue. In the above image sense, one was kept in the queue before two. It is the first to be removed from the queue as well. It follows the FIFO rule. In programming terms, putting items in the queue is called enqueue, and removing items from the queue is called enqueue. And basic operation of queue. A queue is an object, an abstract data structure entity that allows the following operations. A query adds an element to the end of the queue. The queue is remove an element from the front of the queue. Is empty, check if the queue is empty. Is full, check it if the queue is full. Pick, get the value of the front of the queue without removing it. Working of queue. Two point two pointers front and rear. Front track the first element of the queue, rear track the last element of the queue. Initially set value of front and rear to 1. Enqueue operations. Check if the queue is full. For the first element, set the value of front to 0. Increase the rear index by 1. Add the new element in the position pointed to be rear. The queue operation. Check if the queue is empty. Return the value pointed by front. Increase the front index by 1. For the last elements, reset the value of front and rear to -1. Program the enqueue queue, display the queue. So yeah, this one. Next, limitation of queue. After a bit of enqueuing and dequeuing, the size of the queue has been reduced, and we can only add index 0 and 1 only when the queue is reset, when all the elements have been dequeued. After rear recast the last index, if we can store extra elements in the empty space 0 and 1, we can make as use of the empty space. This is implemented by a modified queue called the turkey queue. This one, the queue, you can see the picture, the queue, this one. Okay, next, complexity analysis. The complexity of enqueue and dequeue operations in a queue using an array is 0, 1. If you use pop and in Python code, then the complexity might be 0 on, depending on the position of the item to be popped. Application using CPU scheduling. This scheduling, when data is transferred asynchronously between two processes, the queue is used for synchronization. For example, I/O buffers, people's file, I/O, etc. etc. Handling of inputs in real-time system. Central point systems use queues to hold people current. And what is data structure? A stack is a linear data structure that follows the principle of last in the first out, or LA form. This means the last element inserted inside the stack is removed first. The example, you can think of the stack data structure as the pile of plates on the top of another. Here you can put a new plate on top, remove the top plate, and if you want the plate at the bottom, you must first remove all the plates on top. This is exactly how the stack data structure works. You can see to here stack representation similar to a pile of plates. Next, LIFO principle of stack. In programming terms, putting an item on top of the stack is called pass and removing an item is called pop. In the above image, allow although item 3 was kept last, it was removed first. This is exactly how the LIFO or last in first out principle works. You can see here and this one empathy pass basic operation of stack. There are some basic operations that allow us to perform different actions on a stack. Push, add an element to the top of a stack. Pop, remove an element from the top of a stack. Is empty. Check if the stack is empty. Is full. Check if the stack is full. Pick get the value of the top element without removing it. Working of stack data structure. The operation works as follows. Number one, a pointer top is used to keep track of the top element in the stack. And number two, when initializing the stack, we set its value to -1 so that we can check if the stack is empty by comparing top. On pushing an element, we increase the value of top and place the new element in the position pointed to by top. On popping an element, we return the element pointed to by top and reduce its value. Before pushing, we check if the stack is already full. Before popping, we check if the stack is already empty. You can see to here for working of stack data structure. This one empty stack and then pass top one and stack one equal to this one and the last return stack